The right column is the area, which is the area is the corresponding area to the left. Okay, the area is this area here, which is, if you look at this item here, which is again, whatever the area number, whatever the area label up here, that's always the area to the left, right? So again, the z-score is a different entity, right? The z-score is independent z-score, and the area is the percentage of the data to the left of that z-score. So those two items are not the same, right? So again, whatever the area, which is again, as you can see, we have 4 columns, right? We have 1 column, 2 column, 3 column, 4 column. Each column we have 2 items, which is the z item and the area. Whatever this area is, the area is the area to the left of the z. Okay. So again, if they, if they make it if they put the area to the left and the z-score to the right, maybe it's a little bit, more directly relationship. But again, the relationship is just that. Okay.
So is right just 100 minus the left?
Yes, that's what we're about to. That's what we're about to do. So again, looking at this thing here, which is again, that's what we have, which is as long as it's the left, which is again, same thing go, right? As long as the left, if they ask you to find the area to the left, which is the z-score is 2.1, we go and identify where my 2.10, which is now the area that we have is 0.921, right? So again, whatever the area column, that's the area to the left of a given z-score, okay? So question with how to find the area to the left. Now, what about how do we find the area to the right? Well, to find the area to the right is a little bit different in terms that now we know that the z-score that they give us is the area to the left of that item, right? So for instance, if they ask us find the area to the right of the z-score of 1.7, right? So we know, looking at this thing here, which is again, the z-score is 1.7, which is my boundary is 1.7. And I'm looking for the area to the right, which is, everybody see that the yellow shaded region is the area I'm looking for. So we still go and identify the z-score, which is again, if you go identify the z-score, I cut it out, which is again, the z-score 1.7 is corresponding to the area is 0.9554, right? But what is this 0.9954 mean? Well, the 0.99554 is the item to the left, which is the green, not green, sorry, the white face, right? The white shaded region. But is that the region we're looking for? Not, right? We're looking for this region here. We're looking for the yellow region, right? So how do we find this item here? Which is, again, to find this item, we need to take 1 minus that item. Why 1? Because the total probability is 1, or the total percentage that we have is 100%, right? So we have to take 1 minus the item to the left, which is the item to the left is the area from the table. And if we subtract this thing here, everybody see that is 0.0446, which is, again, to find the area to the right, we have to do 1 extra step, which is we have to subtract it from 1, which is 1 is the total possible, the total probability, or the total percentage, right? Again, I say here, if they ask you for if it's in percentage, you have to subtract from 100, because that's the maximum percentage. But if it's in decimal, which is the table give you in decimal, so you have to subtract from 1, because the maximum is 1. Okay, so let's take a look at this example here, which is, again, 4.46%. You move the decimal 2 places. So let's take a look at this example here, which is, let's say that we're looking for the area under the standard normal distribution to the right of 0.95. So last time we find the area to the left already, right? We find the area to the left last time, which is, again, 0.95 is down here, which is 0.8289. That's what we have last time. But remember, again, I just extract out here, which is 0.95 is corresponding to 0.8289. But that's the answer to the left. But because we're looking for to the right, we have to take 1 minus that item, which is, again, 0.1711 or 17.11%. So it's depending on what what your question, as you will see later when we get to 11.7, is depend on what percent that they ask you or what question they ask you, how your answer have to structure. Okay, if they ask you for percentage, you have to convert to percentage. If they ask you for the area, just give them a decimal. Okay, so same thing go, which is find the area to the right of the z-score of negative 0.35. So again, we just go in our chart, we go in our table, and we ask ourselves, well, where is my negative 0.35, which is, again, the corresponding to negative 0.35 is 0.3632, which is, again, is that our answer? No, right? Why? Because that chart, the chart that they give us, the table that we have right here, is the area to the left. And again, to find the area to the right, we have to take 1 minus the item to the left, which give us the remainder item, which is 0.6368, which is 63.68%. Okay. Question with this A or B. Again, that's the only two things different is if it's asked you for the area to the left, life is good, ladies and gentlemen. The answer is in your chart. You're looking for your Z, find the corresponding area related to that Z score. If it's to the right, not so bad, right? You're just looking for a Z, but you have to subtract from 1 or 1 minus the area to find your Z. It's not 1 minus a Z, okay? A Z is different. The area is what we're looking for, okay? So again, let's try one more, which is, again, look at this thing here to find the area to the right of the Z score of 1.1. So again, how do we do this? Which is, again, we go in and we ask ourselves, where is 1.1? Which is 1.1, the corresponding area is 0.8643, right? So again, 0.8643, which is this my answer? Hopefully you say no, because we're looking for the area to the right, which is to find the area to the right, we have to subtract from 1 or 1 subtract that area. And ladies and gentlemen, one thing is, your area, you cannot use a decimal to identify your area, right? Probability cannot be sorry, not decimal. You cannot use a negative number to identify your area, right? So again, probability cannot be negative, right? So again, you always have to take 1 minus that if you're looking for the area to the right. Okay? So same thing go, well, not same thing go, but the last question they will ask you is this, which is, again, how do we find the area between the two z-score, right? So looking at this thing here, which is, again, this is what they ask you to do, or this is what I want you to do, is first identify what your z-score is. Once you identify your z-score on your table, all you need to do is take the higher percentage or the higher area minus the lower area or the smaller area. Right? So let's take a look at this thing here. We are not subtract from 100, but let's take a look at this thing here. Let's say if I actually find the area between the z-score of negative 1.7 and the z-score of 1.1, right? So looking at this thing here, so again, let me identify my endpoint, which is a smaller endpoint. The negative number is on my left. The positive number is on my right. Everybody see that, right? And this is the area I'm looking for. The area I'm looking for is the green shaded area, right? That's the area I'm looking for, because I'm looking for the area between the z-score of negative 1.7 and the z-score of 1.1, right? So same thing go, we go in and we identify where is my negative 1.7, which is negative 1.7. The corresponding area is 0.0446, which is, everybody see that that's what we have is from the left to that z-score. And now, the second thing is we have to go and identify where is my 1.1, which is 1.1, same as before, 0.8643, right? So looking at this thing here, everybody see that, think about this thing here. If you walk from left to right, you walk to Z of 1.1, that is, let's say 86% to make it an easy number, right? So if we walk